So as you can see, we're not your father's AutoCAD anymore. All right. So Autodesk has come a long way for over the last 30 years. Of course, we're known for AutoCAD because that's a billion-dollar business for us, and we don't even market it. People just download it and they use it. But Autodesk has moved into being a $3 billion software company these days, and it's all about the future of making things and really pushing the limits of creativity and business. And what do we do next? Because as the world is fiercely competitive, okay, and what are we doing with our products? How we make products? How we think about products? And so Adam is with me as well because he's one of my business development managers. Works on the East Coast, and so he's got a lot of things to add about additive and hybrid machining that we're doing. Rob Giao, who's my West Coast business manager, is here as well. And so at the end, we'll have Rob come up and maybe say a word or two. Okay. Let's go here. So it took us 2 million years to move from the rock to the hammer. Okay. Not a lot of innovation going on in those days, but fierce competition during that period of our time. Okay. Even though, we weren't very creative, there was a lot of competition that was happening in our lives in those 2 million years, between animals, humans. And then let's take a look at this, flight. It's made of wood and cloth. That's it. So why weren't the Egyptians creating flight thousands of years ago? I mean, this didn't come about until the late 1800s that we actually thought about flight. And it's such a simple concept of just wood and cloth. So where does the future take us? Okay. One thing that's interesting is in 1966, we thought that Captain Kirk was unbelievable, and everyone said, "I wish I could talk into this little device, and I could communicate with people." If you think about the cell phone, came in 1977, but Steve Jobs and the creation of the iPhone in 2007, it took us a lot of years to get from these dreams of entertainment, the movies, to get to reality. And so another interesting thing is 1989, the hoverboard. Everybody wanted one of these in 1989, right? If you were born. I know some of you guys weren't even born in '89. Some of us were. So everybody wanted this hoverboard. Buzz Aldrin, 2014 at the Autodesk facility, we actually, with our partners, we created one. And so now you can actually buy this hoverboard and it's reality, okay? So 2 million years to go from a rock to a hammer. Now what's happening? So this is something that we're all dealing with today. Is this stops in the 1400s with the printing press. Go back 2 million years ago, and it wasn't until about the 1970s when we have this quantum increase in technology. How are we handling that? A lot of you folks are running a small machine shop. Fierce competition from around the world. Feels like it's just pouring on top of you. How do I compete with this? Plus technology is just exploding. So what are you doing to handle this curve? This curve of technology that's going up. I once asked my grandmother, what was the greatest thing that ever happened in her lifetime? She said flight. She was amazing. She was born in the 1920s, and she said, and I asked her this question in the 80s, And she said, to think that you can get on an airplane and go anywhere in the world is incredible to me, because that wasn't something we thought was possible, even though flight was around, but to have mobility like we've turned it into. Then I asked my mother, who's 74 years old, I said, what was the greatest thing that ever happened to your life? It's just the internet. She goes, it's insane. She's like, and she's the greatest Facebooker I've ever seen, okay? This woman is insane on Facebook, but that's what she thinks was the greatest invention of her lifetime, was the actual internet and just the power of that. So how are we dealing with these traditional strategies? Productivity. It's all about inputs versus outputs, fierce competition. And every time we as manufacturers, we try to solve a problem, it's easily copied, okay? So what's interesting about that is, how do you differentiate yourself in this market space? Oh, I'm going to do it through innovation. Great story. Black & Decker, one of our customers, their key distribution networks was Home Depot. That's where Black & Decker sold most of their products, is through there. And so Home Depot did a great thing. They put the Black & Decker products right at eye level, shelf eye level. And if anybody knows retail, that is the prime space. You have to be at eye levels. When you go to the grocery stores, the most expensive, the product they're trying to push the most is at your eye level. If you ever want discounts, you look low and you look really high, because that's where people don't look. So then what did Home Depot do? They went and they created their own business to compete with Black & Decker, their customer, and started creating cheaper products and putting them just below the Black & Decker products, ultimately destroying the Black & Decker product line at Home Depot. So Home Depot's own customer destroyed their partner, okay? That's what's going on. So Black & Decker has to innovate to beat basically their own partners, okay? Fierce markets. You know, another question, I can improve my processes, right? So now I can go out, I can look at how I'm doing my processes, I can change different material types, but also there's a big problem that goes on, is that as soon as you increase or change your process, somebody copies it. You try to control it through IP, you put patents on things, people get around patents all the time. So it's a very difficult world out there that we're all trying to compete in. So then we say, okay, you got me depressed, Joe. You know, I'm trying to innovate. My partners are stealing my business. What else is going on out there? And so then we look at disruptive technologies that say, what's really happening with our products, with our demand? Adam?
Yeah, so I think, you know, you look at the space today, you know, consumers are looking at buying products differently than they were in the past. You know, particularly my dad buys a Ford F-150, buys a white one, goes to the same dealership, hopefully the same sales guy's there, so he can buy that truck from him. You know, for me, I have 4 kids. You know, I need a land yacht that can, you know, it's got TVs and 22-inch rims, and I want them black wheels and black paint, tinted windows. So me as a consumer is different today than in the past. So how are you changing your business to reflect the personalization or the customization of products today? So let's take, for instance, a company called Normal. You know, thinking about personalization, they've totally changed the earbud market. Okay, so you download an app on your phone, you scan your ear. In that app, you pick what color you want the earbuds, what style, and within 48 hours, they'll have these earbuds 3D printed, assembled, shipped to your door for under $200, right? I mean, that's thinking way outside the box of an industry of earbuds, right? How do you innovate? And it's by personalization. And think about CAD design. You know, how much of your CAD is actually aided in design? You know, you physically have to go in there and say, if I'm designing a chair, it's got 4 legs, it's got a seat and a back. Maybe the back's arced, you know, and then you apply some simulation to it and see where your stress is and where you need to make it stronger. But what if you had a software that actually aided you in the design of the chair and spit out multiple iterations and design versions for you automatically? So here's a technology called generative design. And if you look at this, this is a swing arm for the Lightning motorcycle. And at the beginning, it looks like a normal swing arm, but then it starts to generate this shape. It looks really funky and wild and kind of looks like the bones in your body. I mean, if you think about the bones in your body, why are they the shape that they are? I mean, you think the force that your bones go through on a daily basis, you know, and they're designed to optimally take into those forces of you standing all day long.
Here's one thing that's interesting about this type of technology is that the computer, well, actually the engineer or the designer puts in a set of parameters that simply says, I need this type of force, I need this, you know, within this envelope, it has these types of different properties, and the computer goes ahead and generates this geometry. So this, what you're seeing on the screen, nobody knew what it was going to look like until the computer went through 1,000 iterations to come up with this particular design. And what we're finding, it is mimicking the human body. We are finding components that start to look like the human body. And when you look at it, our bodies have evolved over time to manage, you know, our environment and how we deal with our environment.
Yeah, so here's an example of Airbus. You know, everyone that's flown on a plane, you know, there's a partition that, you know, separates first class from the rest of us that sit on a chicken crate in the back of a plane. So this is the partition for the new Airbus A320. And they wanted to figure out a way to make that lighter, right? So what they did is they figured out, I'm going to make a constraint. And this is what the outline of my partition is supposed to look like, right? And it has all these forces applied at different sides. And I want it made out of a certain material. And this is the software actually generating hundreds and thousands of different designs that then the computer and the engineer can go through and pick out their best design to then implement it into manufacturing. So this particular partition for Airbus is 55 pounds lighter than the original partition, and yet it's twice as strong as the original partition as well. So you think about the fuel efficiency that this airplane is going to have, right? Just reducing 55 pounds just on a partition. When you think about designing the whole aircraft generatively and how much more lightweight the plane could be and how much stronger that plane can be as well.
Yeah, so the aerospace industry has been very serious about looking at additives, looking at different ways to create geometry because of this war of weight attrition. We want to get rid of weight. But we just recently announced that General Motors is the first large automotive industry partner that's going through re-looking at every single component within a car to figure out how to reduce weight and look at these types of technologies. How do we take weight out of the car? Okay.
Yeah, and Airbus is saving millions of emissions of CO2 by just reducing that partition of the airplane and reducing 55 pounds in the airplane. I mean, just think that's like removing 96,000 passenger cars from the road. And that's how much efficiency they're gaining, but just by 55 pounds from a partition. And here you have the Port of Rotterdam. So the Port of Rotterdam wants to be the smartest port in the world. You know, they want to revolutionize and totally change the maritime industry. When you think about these impellers or these propeller blades in the back of these container ships, I mean, there's long lead times, and every container ship has a different type of propeller. So what they did is they invested into robots, metal additive printing, subtractive machines. And right there in the port, when a container ship comes in, they can 3D print their own propeller and machine it to put right on that cargo ship, right in their facility. So they built this facility called Ram Lab. It's one of the smartest machine shops in the maritime industry today.
Yeah, so it's all about on-demand machining or on-demand production. And so this is a photo of the convergence of two worlds. One is construction and the other is manufacturing, where we're starting to put manufacturing small miniature portable facilities right on site at a construction facility where they're creating components right on demand. And also a lot of modular design is being done as well, where they're creating off-site and they bring in the module components and put it right on construction sites. So your companies no longer just create just a simple component, but maybe the full modular design of a particular part, component, or building that then is delivered in this world. And one thing that's interesting about Autodesk is because we own about 80% of the architecture market and construction world from a design perspective, CAD design with our AutoCAD, Revit, but also merging that with our manufacturing business line, which is about another $800 million business. We're combining these two worlds together, opening up a lot of new markets for people to think about, where do I go and get new business? Because it's all about helping our customers get more business, but also opening their eyes to the future of how we're going to make things and different proposals on how they can get involved in that market as well. And here's a great example of a partner like Mazak, who's looking at the hybrid approach, right?
Yeah, so I think, you look at our generative design parts, you think, Adam, that's great. How the hell am I going to make it, right? That's the next step, right? We can create these wild and crazy looking parts, but then how do you manufacture these things? So we're working with Mazak and in our own technology, we have to figure out how that part is even manufacturable, right? I can design it and I can design a really crazy looking part, but how do you manufacture it, right? What machines do you have at your facility? And what's the capabilities? Do you have a hybrid machine, or is it just strictly additive? Do you have a 3-axis mill? Because we still have to do datums, and we still have finishing area tolerance parts that we have to then add subtractive toolpath to. And so technology like these Mazak machines are helping us, bring our parts to market as well that we're generally designing.
So one of the things that we want to highlight is that there's also a huge resource constraint in our business. We get calls all the time saying, do you know anybody who knows how to program a 5-axis machine? Think about in the future, okay, which is actually today, generatively creating thousands of iterations, printing them on your machine, and then having someone that has to actually go in, figure out how to generate the tool paths, generate all of the additive principles that go inside of it. How are we training these people? How do we get them up to speed? How does that happen inside the business? So it's all about your partners and how we're looking at it, trying to automate these workflows for customers. So when you get new people into the industry, it isn't a 30-year process to get them up to speed, because a lot of folks goes, look, I learned my CAM software 30 years ago, and I don't change because I don't want to go through that process ever again. And I know it's too difficult to move away from these technologies. But here's the thing. Technology is not waiting for you. The future's not waiting for you. It's flying almost straight up. Okay? And how are you keeping up? And that's one thing that this presentation was all about is, what are you doing to keep your people involved? What are you learning of the industry? And what can you take from from these presentations and apply them to your business? And one of the things, just quick, with our customers, because you guys are pushing us in a lot of ways on how do you become. I can slide it. Steve may have to give us some help there. Oh, there you go.
We are unique in what we do here. I've never seen anything like this before.
People come to us with challenges and problems where typically they don't know how it's going to be done.
Here within Autodesk Technology Centre in Birmingham, we make the impossible happen. We work with real organisations around the world who have these manufacturing challenges today. They need to get parts produced. They need to take advantage of new manufacturing technology.
We're working with a huge spectrum of customers in all kinds of different fields. It's a very dynamic problem-solving environment. some of the coolest things we've done, we aren't allowed to talk about. Some of the most impressive customers we're not allowed to name.
We might have an automotive customer who's maybe got an urgent project that they're working on. We get involved with a huge variety of aerospace projects and activities where organizations are developing new manufacturing processes.
We have got AS 9100 accreditation, which is a quality assurance for aerospace. So again, we are serious about manufacturing here.
We have 5-axis machine tools, mill turn centers, we have robotic solutions, we have machines which can do high rate deposition for additive manufacturing. We even have hardware platforms which enable us to combine additive and subtractive on a single device. We work with customers who have challenging problems, help them develop the new manufacturing processes to enable those organizations to make anything.
I'm proud to have been a part of the redevelopment of this facility over the last 12 months. Autodesk is invested heavily in this facility, which I think reinforces their commitment to manufacturing. The future's looking good.
So, with that, we just kind of wanted to, share with you, some of, things that might be on your mind of where are we going? Where are the products going? Where are the processes going? How are people innovating? What's disrupting the market? And it's something that we all have to pay attention to because the world's changing every day, very, very quickly. Lots of things are moving. Things are changing, and what are your partners doing to stay on top of it? And we think Mazak is one of those companies that is very forward thinking. They're driving the technologies. They're investing in new machines to create a lot of new and very creative products that are out there faster and better than than the competition. So we're very proud to be part of the Tech Talk today with Rudy and the team, and we think that the Mazak partnership is fantastic and something that we definitely as Autodesk want to be part of, and we're glad to see that you guys came out to be part of it as well. Hi, Rudy.
Our next speaker is President and CEO of Precision Machine Products, here to talk to us